We are still in section 3.3. This is the fourth and final video in this section. So if you would please, you're going to have to go quite a few pages down until you get to what we call Descartes' Rule. Descartes' Rule. Descartes' Rule, there's this gray box is so wordy. So let me explain to you what it's dealing with here. This is a trick for finding how many zeros you're looking for. And so notice that part A says the number of positive real zeros. Okay, so right here we're looking for positive real zeros. And here's going to be the number of negative real zeros. So this is going to be a trick for finding positive and negative real zeros. I'm sorry, for finding the number of positive and negative real zeros. So the number of positive real zeros of my function is either going to equal the number of sign changes or is going to be less than the number of sign changes by a positive even integer. Okay, wait, what does that mean? Let's say that I have 4 sign changes. If I have 4 sign changes, then I'm either going to have 4, 2, or 0 positive zeros. If I had 5 sign changes, I'm either going to have 5, 3, or 1 positive zeros. That skipping even integers there, that's what this means. Okay. How do I find how many negative real zeros I might have? Very similar. Again, it's either going to equal the number of sign changes or it's going to be less than the number of sign changes by a positive even integer. Here's the catch. Here's the clincher. Not of my original polynomial, but of f of negative x. So an example again of this one, this is very similar to the last part. 4, 2, or 0, negative zeros. If I have 4 sign changes, I'll have 4, 2, or 0 negative zeros. If I have 5 sign changes, I'm either going to have 5, 3, or 1 negative zeros. All right, let's put this into practice so that you can see what it looks like. So you'll notice here that I have a polynomial and I'm looking at sign changes. So notice that this guy goes from a negative to a positive. That's a sign change. The one I currently have circled is positive and it switches to negative. That's a second sign change. The one that's circled is a negative. It switches to a positive. So that's a third sign change. And then this one, switching over to this one, is a fourth sign change. So I have 4 sign changes on this. So the first thing that you want to do is you want to count how many sign changes you have. I have 4 of them. So since I have 4 sign changes, what that means is that I'm either going to have 4, 2, or 0 positive x-intercepts, positive zeros. Okay. Now, that was all running this little test, this little rule on the original polynomial. So in order to find how many negative x-intercepts or negative zeros I might have, we need to go find f of negative x. Now, I didn't show my work on this. All right, but you should by now be able to figure out what f of negative x is. And you'll notice that I have no sign changes. Every one of these is negative. So there are no sign changes, but the first thing you want to do is find f of negative x, count how many sign changes you have. I had 0 sign changes, so this means I have 0 negative x-intercepts, 0 negative zeros. Now, just a note here, Descartes' rule of sign does not identify the multiplicity. So remember, multiplicity is where I have multiples of the same 0. And honestly, I forget what this note says, so let's go ahead and uncover it. This is just another example saying if I had 3 sign changes, then you would have 3 or 1 zeros, x-intercepts, depending on whether you are working with the positive side or the negative side.